Welcome to the fourth episode of Circuit Series. In today's episode, we are going to look at touch activated alarm circuit. This is the touch activated alarm circuit which we are going to see in our video. So here we use an FSR, which is a force sensitive resistor, as a sensor to detect our touch, and a comparator LM311 to activate the buzzer, which acts as a sounding element for it. So now let's take a look at how a FSR works, because it is the heart of the circuit. Working of FSR. FSR is nothing but a resistor that changes its resistance when force is applied on it. Let's take a look at the graph to understand this better. As you can see here, resistance across FSR will be very high, even in the range of infinity when no force is applied. Resistance of FSR will begin to drop when force is applied on it. Let's say our finger is used to press the FSR. Here, I am assuming the force of our finger will be around 20 newtons. So, our resistance drops to 30 kilo ohms from the range of infinity. So, when further force is applied, and it is being demonstrated by a rock. So, let's say our force is around 1000 newton at this point of time. The resistance will reach to almost 1K. And when the force is further increased, let's say around 10,000 Newton, our resistance drops further down to almost 0.2 K ohms. This resistive property of FSR is used in our circuit to sense the touch. Before heading into working of this circuit, I want to drop a quick note about PCB Wave. They are one of the popular PCB manufacturers in the world. They are trusted by big brands to manufacture their PCBs. Also, they are capable of manufacturing advanced PCBs like flex and rigid flex PCBs. Try out their service and let me know your thoughts. I have left a link in the description for easier access. Now, let's get back to our circuit. As I mentioned earlier, this circuit uses the resistive property of this FSR to detect the touch. In order to do that, we are going to build a voltage divider using FSR and another resistor R3 here. So when there is no force applied on the FSR, the resistance will be very high and even to the point of infinity. But when you consider practicality, infinite resistance is not really possible. So let's assume when no force is applied on FSR, this FSR exhibits a resistance of about 2 mega ohms. So at this point of time, the voltage from this point will be very low. So if we use the voltage divider formula, considering the FSR resistance as 2 mega ohms and this resistance as 200K, our output voltage at this point will be 1.09 volt. Whereas when you press a finger to this FSR, the resistance will drop considerably. So let's say our finger exhibits a force of about 20 Newton. At this point, our resistance across FSR will drop to about 30K. Now, using the same voltage divider formula, we can understand that our output voltage at this point will be considerably high and it will be 10.09 volt. So now we can deduce that when a force is not applied here, the voltage will be very low, and when force is applied here by means of a thumb or finger press, the voltage will be very high. So using this logic, we are going to use it with a comparator and activate this circuit. Here's our complete touch activated alarm circuit. As you can see here, the voltage divider built using FSR and resistor R3 connects to inverting terminal of comparator, and another voltage divider made up of R1 and R2 connects to non-inverting terminal of comparator. So we are using comparator here and not an op amp. There's a significant difference between an op amp and comparator. Please check out the link in the description where I have listed some key differences between an op amp and comparator. Now, a comparator compares the voltage between these two terminals and changes its output based on that. When no force is applied at this point, the output voltage will be very low, as I said earlier. Now, this R1 and R2 divides the incoming voltage of 12 volt to 6 volt here. So at this point, 6 volt will be at non-inverting terminal of comparator and 1.01 volt will be at this inverting terminal of comparator. Therefore, output will be high, and this buzzer is connected in a manner in order to sync the current from the buzzer to activate it. So therefore, the buzzer will remain inactive at this point. Now, when a thumb is pressed, applying force to it, the voltage at this point will increase to about 10.1 volt. So at this point of time, the voltage at this point will remain at 6 volt. So now the voltage at inverting terminal is higher than non-inverting terminal. Therefore, output of comparator switches to 0 and therefore sinking the current from the buzzer. This activates the buzzer. So in a sense, as long as the force is applied here, the buzzer will keep on sounding and remain active. So as a result, this acts as a touch activated alarm circuit. You can find the detailed documentation of this circuit in our website. You can find the link in the description below. Check out the circuits library in our website where we have grouped the circuit based on their categories for easier browsing. You can find the link to that in the description below. Hope this video was useful to you. Please hit the like button if it does. Also, comment your feedback queries in the comment section below. Subscribe to our channel to get notified for future videos. Thanks for watching. See you in the next episode.